Hi, I'm Rebecca and this is the CCT for Advanced Functions. This video will outline the steps to solving question 11 on page 237 in the Nelson Advanced Function textbook. In this question, you will need to know what the instantaneous rate of change is and how to sketch the graph of the function, and know the intervals of increase and decrease. But before we solve the question, here's a mini lesson. The instantaneous rate of change is to find the rate of change at a specific point. To find the instantaneous rate of change graphically, it will have to be found by the slope of the tangent to a point on the curve of the function. The tangent is a line that touches the graph at only one point in a given interval, which is the tangent point. Note that the tangent line has to go in the same direction as the function and the tangent has to be outside of the graph. Then finding 2 points on the tangent, use it to sub into the equation IROC equals to y2 minus y1 over x2 minus x1. Make sure that the x and y values of the first point are being subtracted from the x and y values of the second point. The y values have to be placed in the numerator and in the denominator. To find the instantaneous rate of change algebraically, estimate the slope using a very small interval of 0.001 to add and subtract from the tangent point, then substituting the intervals into the equation. In this example, find the IROC at 3 seconds by adding and subtracting 0.001 to 3 for the values of t, and subbing it into the equation to find d. Sub the d values into the y in the numerator and t into the x in the denominator. The intervals of increase within the domain of the function is where the y values get larger, moving from left to right. Since the function has an arrow, the function is continuous. Since it is going towards the negative side, the interval of increase is from negative infinity to 3. The interval of increase is when the slope is positive. The interval of decrease is where the y values of the function get smaller, moving from left to right. Since the function is continuous, the interval of decrease is from 3 to positive infinity. The slope is negative. The question asks the distance in kilometers of a boat from its dock can be modeled by the function dt equals to 1 over 200t squared, t minus 8 squared, where t is in minutes and t is real from 0 to 8. Sketch a graph that models this situation. 11a asks to estimate when the instantaneous rate of change in distance to the dock is positive, negative, and 0. 11b asks, what happens to the boat when the instantaneous rate of change in distance is 0? What does it mean when the boat's rate of change in distance is negative? To plot the graph, you will need to make a table of values. In the t column, which represents the time in minutes, sub in the numbers from 0 to 8 because the domain states that the function is real from 0 minutes to 8 minutes, into the equation to find the d value, which is the distance from the dock. Then plot the points onto the graph. The x-axis is the time in minutes and the y-axis is the distance in kilometers. For part A of the question, the IROC is positive where the interval of increase is. That is because the boat is increasing in distance from the dock. Looking at the graph from 0 to 4 minutes is when the IROC will be positive, because the slope is positive. The boat is increasing in distance from the dock. The IROC is negative where the interval of decrease is. When the boat is decreasing in distance from the dock, the IROC is negative. On the graph from 4 to 8 minutes, the IROC will be negative because the boat is going towards the dock, and the slope is negative. The IROC is 0 at 0, 4, and 8 minutes. This is because there is no change in distance. At 0 and 8 minutes, the boat is parked at the dock. At 4 minutes, the slope is 0 because it stops briefly to turn around to go back towards the dock. The IROC is negative when the boat is headed back towards the dock. This is because the boat is decreasing in distance from the dock. When the rate of change is zero, the boat stops. This is because there is no change in distance. The rate you are traveling at a particular instant is the instantaneous rate of change. This is the information that the speedometer provides. The speedometer is used by professions like a police officer to check the speed of cars on roads, or professions like a sport analyzer that may analyze data for the speed of cars like in NASCAR racing or the speed of a tennis ball in a tennis match.